In this video, we're going to solve multi-step equations using inverse operations and SADMEG. Remember, that's the order of operations in reverse, with the variable only on one side of the equation. These are the steps we're going to follow to solve these equations. If we see a number outside of a parenthesis, we're going to multiply it. That's distribution. We're going to share that number with the parentheses it's in front of. If we see terms that are alike, we're going to combine them. Variables are going to go together and constants are going to go together. Remember, constants are the numbers without a variable. Solving the remaining equation, that's where we use SADMEG, the order of operations in reverse. And then check our work by either using Desmos or by plugging that number back into the equation. As we do these examples, I want you to try and pause the video first and try that example before I go over the solution. So in example number 1, I'm going to split that equal sign so I know what's on the left and what's on the right. I notice that I have like terms that I can combine. The 2x and the 8x both have an x with it. So I'm going to combine those terms. 2x minus 8x gives me negative 6x. And then I bring down the 1 and the 49. Now I notice that this turns into one of our two-step equations where I can undo those operations using SADMEG. So undo the addition by subtracting 1. That leaves us with negative 6x equals 48. Then divide by negative 6 on both sides. 48 divided by a negative 6 is negative 8. So x is negative 8. Here, split that equal sign. I notice on the left there's nothing to combine with the negative 19, but on the right hand side I notice that the negative 5 and negative 11 can combine. Negative 5 minus 11 becomes a negative 16. Then I can add 16 to both sides and be left with negative 3 equals negative 3a. Notice how I brought down that subtraction as a negative in front of that 3. Then I can divide by 3 on both sides. And negative 3 divided by negative 3 then becomes positive 1. So my answer is A is equal to 1. In the next example, split that equal. Nothing on the left to combine with the 19, so I look at the right. I notice that I have some w terms to combine. I also notice I have some constant terms to combine. That's going to leave me with 4w because negative 5 plus 9 is 4, and 10 minus 7 gives us 3. Then I can undo the operation of adding 3 by subtracting 3 from both sides. That leaves us with 16 equals 4w. Then divide by 4 because I need to isolate that variable. And then w is equal to 16 divided by 4, which is 4. Next, I notice on the left-hand side of that equal sign I can combine a positive 2k and a positive 3k. And I can combine the constants negative 6 and negative 7. Now I can undo those operations that are happening to k. I can undo the subtraction by adding 13. That leaves me with 5k equals negative 35. Then I can divide by 5 on both sides and be left with k is equal to negative 7. In the next example, I'm going to first split that equal. Notice on the left-hand side I don't have any terms to combine, but I have that 7 in front of a set of parentheses. This is distribution. I can share that 7 with everything inside that parentheses. Sharing here means multiplication. 7 times x gives me 7x. 7 times negative 6 gives me negative 42. And then I just bring down the negative 14. That 7 is only in front of the parentheses on the left side of the equation, so we don't multiply the 7 times the 14. Now this is a two-step equation. where I add 42 to both sides and then divide by 7 to get x is equal to 4. In number 6, notice I have that negative 2 in front of this parentheses containing k plus 9. So I'm going to distribute the negative 2 to k and to the positive 9. The 16 just comes down. So negative 2 times k is negative 2k, and I have a negative times a positive, which gives me a negative 18. Now I have my two-step equation where I can add 18 to both sides and be left with negative 2k on the right and positive 34 on the left. Divide by negative 2, and k is negative 17. If I were to plug that negative 17 back into the equation, I would get the sides that are equal. On number 7, notice I can distribute the 4. The 4 is going to multiply by 3 in and negative 1. I bring down the negative 52. 4 times 3 in becomes 12 in. 4 times negative 1 becomes negative 4. Then I can add 4 to both sides because I'm trying to isolate the variable. So whatever's on the side with the variable, I need to get rid of. That leaves me with negative 48 equals 12 in. Divide by 12 on both sides, and negative 48 divided by 12 is negative 4. Okay, when I split that equals here, I'm distributing a negative 1/2 to 12p minus 42. So negative 1/2 times 12 becomes negative 6p. A negative times a negative here becomes a positive, and half of 42 is 21. And I bring down the negative 33. Now I can subtract 21 from both sides and be left with negative 6p equals negative 54. When I divide by negative 6, I'll get a negative divided by a negative, which is a positive 9. Okay. On these next couple of examples, this is why it's so important for you to split that equal. So when I split that equal, I notice the 7y is on the same side as this distribution. And then I have the negative 32 over here. There's nothing to combine with the negative 32. But I do notice the 5 that's being multiplied by those parentheses. So I need to distribute the 5. The 5 gets multiplied only by the y and 2. We stop distributing when we stop the group. So 5 times y becomes 5y. 5 times negative 2 becomes negative 10. The 5 does not get distributed to the negative 7y because it's not inside the parentheses. So we just bring it down and bring down the negative 32. Now I notice that I can combine the 5y and negative 7y. And this becomes negative 10 minus 2y equals negative 32. Now I can add 10 to both sides and get negative 2y equals negative 22. Divide by negative 2 to get y is equal to 11. Right on this side, I'm going to split that equals, and notice I have a negative 3 plus 2/3. I cannot combine those because the 2/3 is in front of that set of parentheses. I need to multiply the 2/3 times the parentheses first before I can combine any like terms. So I have 2/3 times 6 in and 2/3 times negative 42. The negative 3 is just going to come down. So 2/3 of 6 is 4. 2/3 of 42 is 28. Now I notice I can combine a negative 3 and a negative 28. So I have 4n minus 31 equals negative 51. Then I can undo those operations with adding 31 and then dividing by 4 to get n equals negative 5. All right, next, in example 11, I split that equals, nothing to combine with the 57. Now I can distribute the negative 3, but I only distribute it to the group that it's in front of. So bring down the 57. Negative 3 times 4 is a negative 12. Negative 3 times a positive 1 becomes a negative 3. The negative 3 does not get distributed to the 2v because it's not in the parentheses. Now combine like terms on that right-hand side. The negative 12 can combine with the 2 because they're both terms with a variable. So I have negative 10v minus 3, and I brought down that 57. Now I can add 3 to both sides to undo that operation, and I'm left with 60 equals negative 10v. Divide by negative 10, so that v is negative 6. Example 12. I'm going to distribute the 7 to the 3k minus 2. So 7 times 3k becomes 21k. 7 times negative 2 becomes negative 14. Bring down the 13k and the 82. Now I can combine those like terms of the 21k and 13k. That becomes 8k. Bring down the negative 14. Now you can add 14 to both sides and be left with 8k equals 96. Divide by 8, and k is 12. Remember to try and pause and do these problems before we get to the solution. All right, in 13, when I split that equal sign, I have a negative 15 minus 2 times c minus 1 minus 3c. This negative 2 here is in front of that set of parentheses, so I need to distribute this first. The negative 15 and the negative 3c are not in those parentheses, so I just will bring those down. So I'm going to have negative 3 equals, bring down the negative 15, negative 2 times c becomes negative 2c, a negative times a negative becomes a positive 2 here, and then bring down that negative 3c. I can now combine my constants with constants and variables with variables, and that leaves me with negative 3 equals negative 5c minus 13. Now add 13 to both sides, and then divide by negative 5 to leave me with c is equal to negative 2. Here, I have a set of parentheses, but it looks like there's not a number there. There really is. It's really a 1, but it's really a negative 1. So we're going to be distributing a negative 1 to that set of parentheses. Bring down the negative 18 and the 5. Negative times 6k becomes negative 6k. Negative times a negative here becomes a positive. Combine your like terms. 5 and 19 becomes 24. Bring down the negative 6k. Now you can subtract 24. Negative 18 minus 24 becomes negative 42. Then I can divide by negative 6 on both sides. A negative divided by a negative is a positive 7. In these last two examples, I'm going to distribute a negative 3 here. The r is going to come down. The 4 is going to come down. So I have r minus 3r plus 27 plus 4 equals 5. Combine your like terms. R minus 3r. There's really a 1 in front of that r. So that becomes negative 2r. 27 plus 4 is 31. Subtract 31 and then divide by negative 2. In this last example, I'm going to split that equal sign. Notice I actually have two sets of parentheses here. I have to distribute the 6 to this first set, and then I have to distribute a negative 1 to the second set. So 6 gets multiplied by the 8 and the negative 3x. A negative 1 gets multiplied by 2x and positive 1 here. So 6 times 8 gives me 48. 6 times negative 3x becomes negative 18x. Negative times 2x becomes negative 2x. Negative times a negative 1 becomes negative 1. Now I need to combine like terms. The negative 18x and negative 2x become a negative 20x. 48 minus 1 becomes 47. Now I can subtract the 47 from both sides and be left with negative 20x equals 60. Then divide by negative 20 to get x equals negative 3.